All right. So today we are going to be talking a little bit about corresponding angles. But before I wanted to get into the details of that, I wanted to talk a little bit about kind of just some strategies that we're starting to employ because I've thrown a lot of terminology out at us. We've talked about angle sums. We've talked about complementary angles. We've talked about supplementary angles. We've talked about vertical angles. I'm going to put another one out there again today. So we have all these strategies. And so what you're going to start to see is similar to the problem in front of you now. You're going to have to build on them and probably going to have to use multiple kind of techniques. If you are at all stuck, you kind of look at this problem and you're just like, I don't know what to do. Instead of focusing so much on like what is the goal or what is the thing I'm trying to answer, which in this instance is this X. So instead of saying like I gotta find X, I gotta find X, just start by putting down what you do know. You'll find that there's usually multiple ways to get to an answer. And so just kind of tossing out more information is better information in this instance. So don't limit yourself to just saying, like, I got to get to this X. Instead, say, you know what, if I write something down, it's probably going to help get me closer to the X. And if it doesn't, like, what's the damage, right? And so in this instance, we really don't know what's going on in this triangle because we only have one corner, this guy up here at the top. I would point out that unless you see that right angle symbol, you should not assume that it's 90 degrees, but it does have the symbol, so we're going to say, all right, we know this bad boy is 90 degrees. But knowing 90 means I can't say that's 45 and that's 45. That would make 180, but how do I know that this isn't 46 and this is 44? How do I know it's not 47 and 43? There's nothing that's pointing me in a direction here in regards to that triangle. So I got to take a big step back and say, well, what do I know? Well, I got the 90, and I also have 132 over here. Well, that's my starting spot. Is the 132 is a part of a supplementary angle, or 180. So essentially, I'm going to subtract these two, and I'm going to say, all right, my 48 is actually going to be on the other side of this 132. Well, that's not going to go. So I'm going to put the 48 here. I'll leave the part that I'm adding in black. I'm going to leave the degree symbol off. I hate when there's no units or symbols on things, but I feel like it muddies the waters. So I will try and start to leave less degree symbols and just assume that since we're talking angles, we know. Does that make the other side 48? No, they are not symmetrical just because they look like they're symmetrical. I have to have a mathematical reasoning for everything that I'm doing. So then I got to stop and say, all right, what else do I know? I still don't know what is opposite this x. I have no numbers over here, so this whole thing is unhelpful to me. But now I maybe know enough to say, all right, I can see I got a triangle here. So I can use the angle sum of a triangle to help me out. What would that be? Well, that's going to be 90 plus 48, 138. And I know that the triangle itself is 180 degrees, so if I already know what 138 of them are, what's left is going to be my remaining angle, 42. So I took, well, and then I'll finish it up by saying like, oh, hey, last week we learned this very fancy thing that this x is going to be the same as this thing, that vertical angle approach. And so using that rule, I can say I know that x is going to be 42 degrees. Voila, I am done. I'm just pointing out here that it is increasingly likely in this instance that you needed multiple steps. So my first step was to use the supplementary angles. My second step was to use the angle sum of a triangle. And then my third step was to use a vertical angle strategy. So if you think back to that original problem, I had a 132 way over here and then very little information, and I sort of needed to work my way across the image. That's going to be what our problems look like. As I usually write at the top, there's no measuring. That's not going to help. Guessing is just, we're way beyond that. So having these as kind of a reference to say, all right, which ones of these can I use? And even if you end up with information that isn't helpful, so if I found this one, for instance, that doesn't answer X, but it wouldn't hurt to know what that is. And so that is the direction that I'm going to kind of steer you towards, is to think about all of these tools that we're building up and saying, all right, which ones do I need to use at any given point in time? Because it isn't just going to be like, we'll solve the one right next to it. It's going to be about these increasingly complex designs and saying, all right, I'm going to have to apply a lot of different tools to get to the corner of the actual answer. All right, so I actually put a little key over here in the corner of like kind of what tools we have built up. So angle sum, we know triangles are 180, and then as you add more sides, it goes up by 180 each time. So a quadrilateral, which has 4 sides, would be 360. A pentagon, which has 5 sides, would be 540. You don't have to remember that. We just talked about ways that you could solve it as the shapes become increasingly complex. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. And vertical angles are the angles across from each other at an intersection. All right, so corresponding angles. My lines aren't going to be as nice and neatly straight. Sorry about that. Corresponding angles take place when we have 2 lines and we have something that are parallel. That's the parallel symbol. And it only works if they're parallel. And you have a line that crosses them. It could cross them at any degree or angle, whatever. It is called the transversal. Trans meaning to go between, like translate, go between. Transversal means to go between these 2 lines. And what ends up happening, and you can kind of start to see it, and it's really cool if I had a way to really measure this, and that my lines were perfectly straight, which they're not. But even just kind of eyeballing it, it's something that like it looks like it makes sense, and it does, and it does. We know as a rule from a vertical angle that like this guy right here is going to be the same as this one across from it. What the corresponding angles do is say like, hey, if I were to kind of take a snapshot of this whole intersection, it looks a lot like this intersection right here. In fact, it looks identical to it. And that's because it is. Essentially, the rule of corresponding angles is taking that idea of like this vertical angle is the same as the one across from it, and that is congruent to the same intersection down below. So everything that we have marked there in red is congruent. When they draw the little angle inside, sometimes that's what we're drawing attention to, is like, hey, this is the same as that. Which allows me to take data from sort of the top half of my design and translate it down to the bottom. You could continue to solve, but you don't have to because of this rule. Points out that, and I can't use the 1 bar, so you'll see I'll draw a double bar here to show that that is going to be congruent to that, vertical angles. And the congruency translates to the bottom as well. All of the double angles, which I did in blue, but you don't always have access to colors, so the double angles there are all congruent. The single angles are all congruent. That's what corresponding angles mean. It's sort of taking the rule of vertical angles and applying it to the next step. You can translate it down to transversal, actually as many times as you want to be honest. If I drew another line, I would have another exact identical intersection, which the measurements would be the same for. So I'll keep it short and sweet with this example. We have our 2 parallel lines. Again, remember corresponding angles only work if these lines are parallel. I've got my transversal. I know a little bit of information. I got a right angle here. That's 90. I got a 38 degrees. And then, but the x that I'm trying to solve for is way down here. So I'm going to kind of try and put into practice that idea of like using multiple skills to get to my solution. And what's nice about this is as we have more and more skills, there's actually several different ways that you could go about solving this. Some people might look to say, I know that angle is 90, and then what that is, and kind of work your way around. I'm going to skip directly to the corresponding angle part of it. So if I've got a 90 and I've got a 38, I'm going to use that to fill in what this rest of this one is. You could look at it as either a complementary with 38 or a supplementary with all of them, but I know I need 180 degrees to make that straight line, and I've got 128 of it so far. So the part that is remaining is 52. Yeah, double checking my math in my head. So I know that this is 52, and using the corresponding angle fact, I know that if that is 52, too many circles, that is 52. Yeah, star. I know that this down here is also going to be 52. All right. So you can see our tools growing and expanding. It gives us some options. Can also make the problem seem a little daunting. So like I mentioned at the beginning of this video, if all else fails, start just solving for everything that you know and kind of take it from there.